Hi kids, we are going to go over 9.8, which is entitled Pythagorean Theorem in Space Figures. The essential question is, how can I use the Pythagorean theorem to find missing lengths in 3D figures? So we're going to look at 3D figures, which can be kind of difficult to do on a two-dimensional piece of paper. So we're going to do our best to draw some really good pictures and try to find the right triangles within the picture so that we can use Pythagorean theorem with them to find missing lengths. So there are two particular 3D shapes we're going to focus on, rectangular prism and square pyramid. So I want to make sure you know what these shapes are and how to draw them. A rectangular prism is what you think of when you think of a box. So it's made up of 6 rectangular sides. So the way that you would draw it, you would start off by drawing just a rectangle. And then you would draw a diagonal line from each vertex. And if you really want to make it look 3D, this one right here, you would make it like a dotted line. Then you would connect these two with solid lines. You would go down from this point to this point as a dotted line, and then to this other vertex as a dotted line. So this is kind of how you would draw a rectangular prism. A rectangular prism has 12 edges if you were to count them. Let me show you where those edges are. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, and then the edges you can't see, 10, 11, 12. So there are 12 edges. The faces are actually the surfaces, and there are 6 faces. There's a top, a bottom, 2 sides, and a front and a back. And then there's this new concept of a diagonal in a 3D shape. Now, on a surface, let's look at the bottom surface of this. If I was to draw the diagonal, and it looks really weird because the bottom surface looks like a parallelogram as drawn, but I drew it like that so that it would look three-dimensional. I know that it's really a rectangle. The diagonal would look something like this. Okay? And then right here in the corner, this is a right angle, but it's really hard to tell from this angle. I've got a prop that I'm going to bring to class, and hopefully you can look at that and kind of see it a little bit better. That would be the diagonal of one of the sides. But there's this idea of a diagonal of the prism, and that's going to go from opposite vertices. So it's going to look something like this. Oops. It's kind of ugly. And if you look kind of in the shape, you see a triangle made with this side, that diagonal I just drew, and the previous diagonal I just drew. That is a right triangle. There's actually a right angle right here in the corner. But that diagonal I drew right here, there are actually 4 of them in the shape. I have 8 vertices total, and that means there are 4 pairs of opposite vertices. I'm just going to draw one in my picture because I don't want my picture to look crazy. But there are 4 diagonals, and what's cool about these diagonals is that they're all congruent, and this is super easy to remember. So if you're asked to find the diagonal of a rectangular prism, it doesn't matter which one you draw in your picture. They're all going to have the same length. Now how you find them is another story, and that involves 2 right triangles, particularly the 2 right triangles that we drew. If you look at the right angles that I drew in my picture, they both belong to 2 different right triangles. So you'd have to use both of those to find that green diagonal length. Okay, let's go ahead and look at the square pyramid. A square pyramid has a square base, and the way that we're going to draw it so that it looks three-dimensional, it's kind of going to look like a rhombus, right? So all of the sides are congruent. And then if you draw a point above it, excuse me, and connect that point to each vertex of that square base, hold on just a second. I'm going to move my point over a little bit so I can make it a little more dramatic. And if you draw that to each vertex, it begins to look like a pyramid. If you draw this last one in the back as a dotted line, it hardly looks dotted, it starts to look even more like a pyramid, more three-dimensional. Now, in a pyramid, there are a couple different things that we need to know about. One, the base. The base is this down here. Okay, that's my base. And there's just one base, and it is a square. There's also one vertex. Actually, there are 5 vertices, but there's one that we call the vertex, and it's up here. It's at that top point right there. Excuse me. There is also one altitude. We know altitude is a height. Now in two-dimensional shapes, the altitudes always make a right angle with the base. In three-dimensional shapes, the altitudes also make a right angle with the surface base. So if I drew a dotted line from that green vertex, and perhaps I should use another color so you could see this a little bit better. I'll do it in red. If I draw a dotted line from that vertex to the very center of the square, it's actually a vertical line that goes straight through the center of the pyramid. And there's one of those. If I were to also draw a dotted line from that center to the middle of one of my sides, right here, it would make a right angle with that. Okay? There's one other thing, and it's called the slant height. This is super important. There are actually 4 slant heights, and just like the diagonals of a rectangular prism, these are also all congruent. So this is something important to remember. So if you needed to find the slant height, you would just need to draw one of them on your picture. I'm going to go ahead and draw the slant height. It goes from the vertex to the midpoint of one of the sides. So it actually is on the surface of the pyramid. It's right here. Let me go ahead and highlight that for you so you can see a little bit better. We'll do orange. This is the slant height. Okay, so we've got slant height. There are 4, they're all congruent. There's a little right triangle right there in the square pyramid that is made of the altitude and the slant height, and that little segment down at the bottom that goes from the center of the square base to the middle of one of the sides. And then again in the rectangular prism, we've got those 4 diagonals. So this is really going to be our focus here, finding the length of those diagonals in the rectangular prism and the length of the slant height in the square base pyramid. The biggest hint I can give you for all of this is to look for right triangles. You're going to start with finding a right triangle that belongs to the length you're trying to find the length of, and then see if you know two sides of that right triangle. If you do, you can use Pythagorean theorem. However, if you do not, see if there's another triangle whose edge is a part of that first right triangle that you found that perhaps has enough information to find that length using Pythagorean theorem. So that's kind of what we're going to do in this lesson. Okay, so in this example it says the dimensions of a rectangular solid are 3, 5, and 7. These are the length, width, and height. It doesn't really matter where you put those dimensions, just make sure that they're all different dimensions. Don't label two vertical lines different lengths. So you'll have a vertical line, a horizontal line, and then kind of like an angled line. It wants us to find the diagonal. Remember, the diagonal is this line right here. Okay, so the first thing we're going to do is label our dimensions. So I'm just going to say 3 is my height, 5 is my width, and 7 is my depth. Okay, I can also put the 7 over here for that distance. I could also put the 3 here for that height, and you can put it on here multiple times if you need to. Okay, in order to find that diagonal, it is a part of a right triangle. This right triangle right here. Okay, we only know one side length of that. We need to find, we need to find this distance. That's the diagonal. We know this distance. So the first thing we're going to need to find is this distance right here. Okay. To find this distance, that is a part of this right triangle at the bottom. And we do happen to know two of its sides, the 7 and the 5. So what I'm going to do is I'm going to redraw it off to the side so that it is, so we're looking at it dead on, not at this weird angle, because it's hard to see. Notice there is a right angle in this corner, so it's going to look like this when we redraw it. This has a length of 7, this has a length of 5. Okay, so this right here is this distance right here, and we need to find that so we can use that with our other right triangle. Okay, so we're just going to use Pythagorean theorem. Got our A, B, and C. So the math part of this lesson isn't hard. It's not new. The hard part of this lesson is actually picking the right triangles, the right triangles, and drawing them properly, and being able to decipher how long each part is. So let's go ahead and try this. A squared plus B squared equals C squared. A is 5. B is 7. Trying to find X, or you could leave it as C. 5 squared is 25. 7 squared is 49. When you add those, you get 74. The last step is to take the square root of both sides. The square root of x squared is just x. The square root of 74, I'd like to see if we can simplify that. So I'm going to go off to the side. 2 will go into 74 37 times, but I believe 37 is prime. So that means the square root of 74 is already simplified. That is the distance of this line right here, which we need for our right triangle. Okay, so now let's take a look at the original right triangle that we looked at. That is this one right here. Okay, I'm going to go off to the side and I'm going to redraw it. It's going to look like this. This is 3. Here's my right angle. I just found this bottom part to be square root of 74, and I need to find this. This is my diagonal. So let's go ahead again and use Pythagorean theorem. we've got A and B, we need to find C. A is 3 squared, or A squared is 3 squared. B squared is square root of 74 squared. And my C I'm calling D. You can leave it as C if you'd like. Okay, 3 squared is 9. Square root of 74 squared is just 74. And this equals D squared. 9 plus 74 is 83. The last step is to take the square root of both sides. And I have a feeling that 83 is a prime number. I'm pretty sure that it is. So the distance of our diagonal has a length of square root of 83 units. This is our answer. So in order to find the length of the diagonal of a rectangular prism where they give you the length, width, and height, you're going to have to use Pythagorean theorem twice. Just make sure that you're picking the right triangles. Okay, last example. This one is using a square-based pyramid. We know that the perimeter of JKMO is 40. JKMO, if you look at the picture, is the square base. And I know it's a square because I see the tick mark, so all the sides are congruent. If the perimeter is 40, that means each side of that square base is going to be 10. And then this guy over here is 10. Okay. We also know that PK is 13. PK is one of the edges. I'm trying to think how we're gonna. That is 13. Okay. We're trying to find JK. Oh, JK is 10. We just found that. So there's one of the things we're supposed to find. PS. Did I mess up somewhere? I'm sorry, there's one other point. Point S is right here. It's the midpoint of that side. And we're also supposed to find RP. PS, excuse me, is that orange line, and RP is that green line. So we've got to find the orange and the green line. So we need to look for right triangles. I see the right triangle made by the green and the orange line. So I think I'm going to go ahead off to the side and draw that. Okay, so if I look at this triangle that I redrew, and I left the green and the orange so you could see it easily from the original picture. We don't know PR or PS. Those are the two we need to find. RS, if you look at it, it should be half of that 10 length of the base. So it should be 5. Okay, so at this point we don't have enough information to find the green or the orange. So we need to be looking for another right triangle. One thing that you need to know about the slant height that I might not have mentioned before, that orange line, where it hits that edge of that base, it actually makes a right angle there. And so I don't know if you can see the triangle that's made by the orange slant height, the right angle I just made, that half of that edge, and then PK, that 13, that actually is also a right triangle. So I'm going to draw that and see if that will help me. Okay, so I have redrawn this. You can look at my vertices to locate where this triangle is. And let's see if we know any of these sides. PK was one of the sides that was given to us. This is 13. Okay? KS is half of one of our edges of our square base. So since each base edge is 10, it's going to be 5. So I could easily use these two sides and Pythagorean theorem to find the length of that orange side. Okay, so let's go ahead and do that. Okay, so we've got A, B, and C. is 5, so we have 5 squared. B we don't know. C is 13, so we have 13 squared. 5 squared is 25. B squared we're not sure. 13 squared is 169. Then we're going to subtract 25 from both sides. So B squared equals 144. Oh, nice number. We take the square root of both sides, and that means B is 12. And B represents PS, which is one of the sides that we needed to find the length of. So PS is 12. Now that we know PS, we can go to our other triangle, and we can put 12 here. And we can use that along with the 5 to find our green side, which is actually the altitude or the height of the pyramid. And that is PR. So let's go ahead and do that now. We've got A, B, and C. So again, we're going to use Pythagorean theorem. A is 5. B we're not sure of. C is 12. 5 squared is 25. 12 squared is 144. When we subtract 25 from both sides, we get that B squared equals 119. And then we have to take the square root of both sides. And I'm just going to tell you, just in the interest of time, that 119 is actually a prime number, so you can try to simplify that, but it won't simplify. So B has a length of the square root of 119 units, and B represents PR, or RP, however you want to call it. So it has a length of 119, or square root of 119. And that's it. So again, with the with both shapes, the rectangular prism and the square base pyramid, in order to find the slant height, or the altitude, the slant height, possibly the diagonal, depending on what it's asking, you may have to use Pythagorean theorem a couple times. So really look for those right triangles. Try to figure out which right triangles do you know two sides of, and then kind of go from there. So here are the 9-8 problems. Go ahead and give them a try. Write down any questions that you've got, and I will see you later. Good luck, guys. Love ya.